Good morning, my lovely kiddos and my future mathematicians. Today we are going to be talking about 8.3a. We are going to be talking about the side triangle similarity. All right, so we have talked about, not explicitly, but we have done the side similarity theorem already. So the side, or SSS similarity theorem says that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So once again, big definition. Let's go ahead and draw a photo to show what I am talking about here. All right, so we're going to have our first triangle here with points B, A, and C. So A to B is 12 units long, B to C is 15 units long, A to C is 18 units long. Then we're going to have our second triangle with points F, E, and D. D to F is 8 units, F to E is 10 units, and D to E is 12 units. Okay, so just like we did before, we're going to set up a ratio of our corresponding sides. All right, so I'm going to choose our shortest sides. Again, I'm going to go left over right. It doesn't matter if you go large over small or small over large, as long as you pick one way and you stay consistent about it. Okay, so I'm going to go left over right or large over small. I'm going to pick my shortest sides. So A, B, to D, F. Okay, then I'm going to pick this side here, more on the bottom. So we have AC to DE. And then our final side, BC to FE. Okay, and of course we can't find our scale factors or see that our sides are proportional without these numbers. So let's go ahead and add these numbers in. AB is 12 units long. DF is 8 units long. We're going to reduce by our greatest common factor, which in this case is 4. 12 divided by 4 gives us 3. 8 divided by 4 gives us 2. And so that is our scale factor for that side. We want all three of them to match. So AC is 18 units long. DE is 12 units long. We're going to reduce by our greatest common factor, which in this case is 6. 18 divided by 6 gives us 3, and 12 divided by 6 gives us 2. Okay, so these match. That's a good sign. Let's check our third pair of sides here. So BC is 15 units long. FE is 10 units long. We're going to divide or reduce by our greatest common factor, which is 5 in this case. 15 divided by 5 is 3, and 10 divided by 5 is 2. All right, so since all three of our scale factors match, all three of our corresponding sides are proportional, so we can say that these two triangles are similar by the side similarity theorem, and we can write our similarity statement, okay? So remember, just triangle. I'm just going to go around the figure. A, B, C. And then here, A corresponds to D, B corresponds to F, and C corresponds to E. All right, let's do one more here. So here we have this triangle with points J, K, and L. J to K is 12 units long. J to L is 13 units long. And K to L is 5 units long. All right, then we have our second triangle here with points R, S, and T. R to S is 12 units long, S to T is 9 units long, and R to T is 15 units long. So again, the first thing we're going to do is write out those ratios of our corresponding sides. So I'm going to do my diagonals first. Okay, so we have JL over RT. So I'm going left over right or small over large in this case. Now let's do the bottoms. So we have KL over ST and that third side of JK over RS. So let's go ahead and put numbers in here. JL is 13 units and RT is 15 units. Since we cannot reduce that any further, that is our scale factor here. For KL, that is 5 units, and ST is 9 units. We can't reduce that fraction either. And since these two already don't match, we know that these triangles are not going to be similar. But just for continuity's sake, let's go ahead and do that last one. So JK is 12 units long. RS is also 12 units long. So we're going to reduce by our greatest common factor, which is 12. 12 divided by 12 is 1. And 12 divided by 12 is 1. 1 over 1 can also simplify to just 1. All right, so none of these match. So these triangles are definitely not similar.